This is a quick review of exponential functions with a focus on half-life. The equation for half-life is y equals a times 1/2 to the x. The 1/2 is because we're talking about half-lives. Y is the amount of substance after x number of half-lives. A is the initial amount of the substance. That's the number that you're usually given in the problem to begin with. And then x is the number of half-lives that occur. It's not time. Remember, you have to use time to find the half-lives. So let's start here. Tylenol has a half-life of 3 hours, and Kim takes 500 milligrams of Tylenol for her pain. The first thing we want to do is we want to come up with an equation specific for Kim. She takes 500 milligrams of Tylenol, so that's her initial amount. That's A. X and Y stay X and Y. We don't know how many half-lives have passed, so we don't know how much is left in her system. This is just starting out. We have Y equals the 500 milligrams of Tylenol times 1/2 to the X. That's our basic equation. If we want to graph this, that's the equation that we're going to graph. Now, how much Tylenol is in the body after 6 hours? So we know we have this equation, y equals 500 times 1/2 to the x. And x is the number of half-lives. Well, it's been 6 hours, and we read back a few pages that 1 half-life for Tylenol is about 3 hours. Now, you all know we talked in class. It depends on the person, but this is just what we're going with. The half-life is about 3 hours. So if it's been 6 hours, how many half-lives is that? Well, that's going to be 2 half-lives. So you can plug in a 2 for x. Y equals 500 times 1/2 to the second. So that means it's going to be cut in half and cut in half. So y equals 500 times 1/4. Which is 125. There's 125 milligrams of Tylenol in the body after 6 hours. Now, the next question we asked was how long until there's only 500 milligrams in her system? Well, if we go back to this equation, sorry, that should be 500. 50 milligrams means that's the amount that's in her body. We want to know when that amount's in her body. So that's y. But if we plug that in for y, we don't know how to solve for x as an exponent. So this is when we went to our calculator and said, okay, now is when we're going to have to graph this. Because we can see it on the graph. We want to know when y is equal to 50. So instead of plugging that 50 into for y, we're going to graph both of these equations on our calculator. We're going to have to play with the window and make sure it's a good-looking graph. So you'll grab your calculator, go into y equals, and plug in both equations. Let's see. 500 times 0.5 to the x. And then because we want to know when the amount is down to 50, we're going to also graph y equals 50. Now, we talked about an appropriate window. X is the number of half-lives. And does it make sense for the number of half-lives to be negative? No. And then y is the amount of Tylenol in her system. Does it make sense for that amount to be negative? No. We can't have a negative amount of caffeine in our body. So when we go to the window, we know the minimum for half-lives has got to be 0. And we know that the minimum for the amount of Tylenol also has to be 0. Now, what about a max for the amount of Tylenol? Well, how much did she start with? She started out taking 500 milligrams. So I'm going to make my max just a little bit higher than that, just so I'm not hitting the edge. As far as maximum half-lives, we've got 10 half-lives on there, and since a half-life is 3 hours, we're looking at 30 hours worth of time there. So I think that's probably plenty. In fact, less would probably be okay, but let's go ahead and look at the graph here. There's our curve for the half-life, and that straight line across is our equation here where y equals 50. And we want to know when that happens on the curve. So we want to look for that point of intersection. The process for that was to hit second and calculate. We want to find the point of intersection. That's the fifth one down. And then we hit enter 3 times. It asks us for a spot on the first curve, the second curve, and then do we want it to guess? And the answer is yes for all of those, so we hit enter. X is 3.3, roughly, when Y is 50. So that means since X is the number of half-lives, if we go back to our equation, X is about 3.32. Is that right? 3.32? Yes. But this is the number of half-lives that have occurred by the time it drops down to 50 milligrams. We want to know how long. So we're obviously asking for time. Every half-life is 3 hours, and we have 3.32 half-lives. So we're going to do 3.32 times 3 hours, 9.96. So about 10 hours would be our answer. So when they give you how much Tylenol, when you're wanting to find time, you're going to have to go through this process. You have to graph. You want to get both equations in there for y equals. You want to set your window to be something that's reasonable. It's going to depend on your problem. When you look at the graph, your process was to hit second, calculate, which is the same as trace, hit 5 for intersect, and then you need to hit enter 3 times. And it's going to give you that point of intersection. Remember, that's going to give you the half-lives, so you have to calculate the time.